Evening, I'm Spot On Weather meteorologist Matthew Euler. Welcome to the latest winter forecast model outlook video. So we're going to take a look at the October issuance of all the long-range climate models just to kind of look at what the new projections are. And what a nice looking shot here. We're approaching middle October now. And look at this beautiful, beautiful scene of fall foliage, fall colors here. A very beautiful looking setting. Look at that clear blue sky on top of it with the reflection of these orange and reddish leaves there on that water surface. Wow, this is a nice shot. And, very appropriate as we're heading into mid-October. So let's get right to tonight's main points here. I'm going to go to the next slide here. Okay, I'm going to break out my little utensil, my laser pointer. Okay, so we'll take a look again, as we do every month, at the CANSIPS, the Canadian winter forecast. We'll look at the European CS5 winter forecast. We'll take a look at the NMME winter forecast, as well as the C3S winter forecast. So that's what we'll go over tonight. Just as a reminder, here's some information about this CANSIPS model. It stands for Canadian Seasonal to Interannual Prediction System, and it's a multi-model ensemble. It's a system using two climate models specifically developed by the Canadian Centre for Climate Modeling and Analysis, as well as the Canadian Meteorological Centre, the CMC. And it provides probabilistic predictions of atmospheric elements from the beginning of the month. So each month we get an update of this, and it runs out approximately 12 months into the future. Now, we won't be looking at all 12 months because our main focus is on the winter forecast. Includes atmospheric elements such as temperature, precipitation, the wind speed and direction, and others. And it does provide global geographic coverage. Let's take a look at the latest updates here from the CANSIPS. We'll start off with the 500 millibar height anomaly forecast. And the breakdown here, the graphics on the left of the slides I'm about to present, that will be your December forecast. The middle graphic will represent January 2024, and this far right graphic will represent February 2024. And I'll do that on all the slides. It's kind of the way I've laid things out for the various elements of the atmosphere. So we're going to start with the 500 millibar height anomaly forecast. Just to reacquaint you with this, whenever you see the yellows and the oranges, that indicates higher than normal heights as compared to climatology from 1991 to 2020. And whenever you see the blue coloring, that indicates lower than normal heights in accordance and kind of compared to that climatology from 1991 to 2020. The blue shading also is representative of upper level troughing. And with upper level troughing, we typically see some unsettled weather conditions as well as cooler than normal temperatures. On the other hand, when we look at the oranges and the yellows, that's indicative of upper level ridges, and with upper level ridges in the atmosphere, specifically the middle level of the atmosphere at the 500 millibar level or 18,000 feet above the ground. When you see the oranges and the yellows, that's indicative of ridges, and the ridges associated with dry and above normal temperatures, dry and milder conditions. So, taking a look at December here at Canadian CANSIPS model, just kind of showing you what we got going on. When we don't have any colors, so in the areas where there's no colors, it's just kind of like the gray scale. That indicates near normal heights for the time of year. All right, so initially in December, what we're seeing is higher than normal heights across Western Canada, and the higher than normal heights extending their way eastward toward Hudson Bay and into the Arctic area. So we have above normal heights in the higher north areas, as well as the western portion, specifically the western portion of Canada. It does extend down to slightly above normal heights across the Pacific Northwest. And overall, this kind of map, what this forecast looks like to me is more of a west to east jet stream, more of a zonal flow for the month of December. Although we do have a little bit of ridging here across Western Canada. By the time we get to January, the CANSIPS 500 millibar height anomaly forecast is now showing a area of lower than normal heights extending from the Aleutian Low out over the Northeast Pacific, right on off the west coast of California, right along the Interstate 10 corridor, the more southern U.S. route, right up off the mid-Atlantic to the western North Atlantic. So I would expect that this, according to this model, this would feature your main storm track right here. And then above that lower than normal belts lower than normal heights, we have an area of above normal heights across Canada, Nice little positive P&A pattern setting up, positive P&A pattern setting up with that ridge axis a little bit more amplified in January, according to this model, right up into the Yukon territories into Alaska, with that downstream troughing into the northeastern U.S. And then over here on the right is the CANSIPS forecast 500 millibar height anomalies for February, and showing a deep, very deep Aleutian low just to the south of the western Aleutian Islands by the time we get to February. And we still see another major zone of storminess. When I look at this blue shading and I see these deeper blues, these darker blues, that indicates even greater lower than normal heights off the mid-Atlantic coast. And so, according to the CANSIPS, this would be an excellent location here for the main storm track to be going on, and more frequency in storms. We still see a positive P&A signature here in the month of February. We still see all those higher than normal heights across Western Canada, right on up into the polar areas. One other thing I wanted to mention, by February, even into January here, you see where the orange coloring is going into Greenland on both of these images in January and February, right in this location. That could be indicative of a negative North Atlantic oscillation. And if that were the case, okay, if you want colder temperatures in the U.S. during the winter season, you really want to have this combination: a positive Pacific North American pattern, positive P&A, along with that negative NAO, North Atlantic oscillation. You get that double whammy with upper level heights out here in Alaska and Yukon territories, and another higher height center into Greenland. You're going to have some blocking over the top if that's the case, and some lower than normal heights in the main storm track south of it, along with cooler temperatures. Looking at the CANSIPS temperature anomaly forecast, this on the left for December, orange coloring above normal temperatures, blue shading below normal, and whenever you just see the regular gray scale, no color, that is indicative of near average or near normal temps. So we do see a little bit of below normal temperatures across Alabama, Georgia, and the Carolinas, according to this model, for the month of December, which is a rarity because, most recently we've seen a lot of milder than normal December months, really, over the last few years. You notice up here we have above normal temperatures across Western Canada in association with the ridging, as well as up to the high north, up to the Bering Sea. If we look at the forecast for temperature anomalies, the CANSIPS temperature anomaly forecast here in the middle for January, now we have above normal temperatures across Hudson Bay, Eastern Canada, right on up to Alaska. And this could be associated with that higher than normal height area that I just showed in the previous slide, the upper level ridging, that blocking over the top. When you have warmer temperatures to the north over cooler temperatures to the south, that's usually the signature we look for. Overall, we have a stripe of below normal temperatures, possibly working our way generally up the coast here of Florida Panhandle, along the coastal areas of Georgia and the Carolinas. Also over Montana for January. We look at the temperature anomaly forecast here on the far right, the CANSIPS forecast showing below normal temperatures from Florida right up to Virginia for the month of February. Now, folks, February, that's the prime time for snow, specifically across mid-Atlantic cities. So if we get colder than normal temperatures at the right time of the winter, we could see some above normal snowfall going on across the mid-Atlantic for the month of February, working our way up a little bit further to the north toward coastal New England. We do see in February that the CANSIPS model is holding in predicting these, it's holding its position in predicting these above normal temperatures from Alaska all the way across Yukon territories and the Arctic area. Looking at the CANSIPS precipitation anomaly forecast now, green indicates above normal precip, and brown is below normal precip, or drier than normal conditions. So for the month of December here on the left, we see nothing but green from the Gulf Coast up through the southeast and mid-Atlantic up to New England. So that'd be associated with above normal precipitation in the month of December, right down to Florida. We see drier than normal conditions over the western U.S. We see above normal precipitation into the Gulf of Alaska in association with the Aleutian low. And then over here in the middle is the precipitation anomaly forecast for the month of January, showing now we have a plume of moisture coming into California, so above normal precip in January in California, according to this model. Also above normal precip along the Gulf Coast, Florida, working our way up to the mid-Atlantic, and even all the way up towards New England in January. And then over here on the far right, we see the precipitation anomaly forecast from the CANCIFS model for February. And you'll notice there's a lot more brown shading over the Midwest, the Ohio Valley, and New England by the time we get to February, indicating drier than normal conditions, as well as drier than normal across the Pacific Northwest. We see more in the way of above normal precip from Southern California, Arizona, New Mexico, Southern Texas, Louisiana, Mississippi, Alabama, Georgia, Florida, right on up to the Carolinas. Now let's take a look at the European ECMWF SEAS5 forecast. Now this particular model produces seasonal forecast at the beginning of each month, and it really became operational back in November 2017. So not a very long track record. We're coming up on the 6-year anniversary in November of this becoming operational. And it's an ocean model with atmospheric resolution and land surface initialization. They're all major considerations of the model. And the grid point resolution is about 36 kilometers. It has 91 layers in the vertical as well to capture some of those like smaller scale processes in the vertical. And it includes ocean, ice, and atmospheric coupling. So that's the nice thing about this model. It couples not only the atmosphere to water with the ocean, but also couples the atmosphere to overlying ice surfaces. So let's take a look at the forecast. European SEAS5 500 millibar height anomaly forecast for December here on the left. The peach coloring, the orange coloring indicating above normal heights for the month of December across the Gulf Coast, the Florida Peninsula, right on our way northward along the East Coast up to New England and to southeastern Canada. And look at this bullseye of blue across the Intermountain West, specifically Utah, Colorado, New Mexico, and Arizona to kick the winter off in December, looking like troughing type conditions setting up here in the western U.S. and ridging in the eastern U.S. That's in accordance with this model. By the time you get to January, look what happens to that lower than normal height anomalies at 500 millibars. It starts moving to the east, centered specifically over portions of Missouri, eastern Kansas, Oklahoma, northern Arkansas. You notice some of these lower than normal heights start working their way eastward toward the East Coast. And then you have all these higher than normal heights above the lower than normal heights across a good chunk of the United States. And then the forecast on the right showing the European SEAS5 500 millibar height anomaly forecast for February, showing some considerable troughing still existing across California, working our way eastward through New Mexico, Arizona, North Texas, Oklahoma, and Oklahoma City and Kansas, as well as Missouri, Illinois. The main spot here, the sweet spot in the month of February, according to this model, for lower than normal heights is going to be from eastern Oklahoma, right along Interstate 40 through northern Arkansas through Tennessee, as well as up to Interstate 64 area into Kentucky, southern Illinois, and Missouri. So overall, if I'm looking at this pattern again, and I'm gonna point this out, all right, based on what I'm seeing here, let me just draw this pen up here, okay. So what I see here is initially, we got this deep trough in the western U.S., and then we got some kind of ridging going on for the east in the month of December. All right, so I would expect, main storm activity with this condition right in this area here in the central U.S. in December if this comes to fruition. Now, what would happen in the month of January with this type of situation? Now we get a little more of the way of ridging here over the west, and then it would drop down into this major troughing feature over a good chunk of the United States before becoming ridging again. And so I would expect in this case, we would get some of the storm systems, the main storm track, to kind of shift a little further to the east in this case. And then over here on the far right, what would I expect? What type of configuration would I expect with this? I'm looking at a really active subtropical jet stream in this case where, the storm track is like this. It could be a little bit further down into the, dipping down here into the Gulf of Mexico and riding up the coast a little bit. But I would expect more of that type of storm track when I look at these height anomaly charts. All right, so let's move on now to the temperature anomaly forecast. And we'll start with December here on the left. Let me go back to let's go back to my pointer. So in the month of December, the European SEAS5 is forecasting below normal temperatures, and it's no shock because we have the upper level trough and lower than normal heights in this location over the western U.S. So this is matching up well with the upper air pattern, of course. And then milder than normal temperatures across the mid-Atlantic down to the southeast, well above normal temperatures in Hudson Bay and southeastern Canada, extending southeastward to Maine. We look at the forecast according to this model, the European SEAS5, and for January, the temperature anomalies Look how that blue coloring now has made it all the way down the Gulf Coast, and it's working its way towards the southeastern U.S. So this is a large chunk of real estate across the U.S. if this were to verify for below normal temperatures in the month of January. All the warmer temperatures associated with this maroon and red coloring to the north over Canada. And then finally, the temperature anomaly forecast over here on the far right for February, showing even a further shift of these blue colors, these below normal temperatures, towards the Ohio Valley and the East Coast by the time we get to February. Looking at the European ceasefire precipitation anomaly forecast, showing above normal precip mainly in this area from Louisiana, working our way through the deep south and southeastern U.S. up to the mid-Atlantic for December. See drier than normal conditions expected according to this model along the Pacific Northwest coast of Northern California. Southern California not getting much in the way of above normal precip, kind of closer to average in December. Over here in the middle, we have the CES5 precipitation anomaly forecast for January. It's much below normal and dry out in the western U.S. And then it's much, this is incredible how this is indicating such above normal type precipitation, very wet conditions for January from Louisiana, from the New Orleans area, working our way to Atlanta, into Columbia, South Carolina, Charlotte, into Virginia. And then over here on the right, showing the same areas from the Gulf of Mexico all the way up to coastal New England for the month of February. That's where the wettest conditions are expected to occur. And we see drier than normal conditions across the Pacific Northwest. So looking at this, I'm looking at, a pretty good storm track, a very active subtropical jet stream, bringing copious amounts of moisture from lower latitudes up into the United States, southeastern area, as well as mid-Atlantic for the winter months. We look at the next model, the NMME. This is the North American Multi-Model Ensemble. It's a seasonal forecasting system that consists of multiple coupled models from North American modeling centers, and it provides 12 months forecast out for 13 key atmospheric variables, and this also comes out at the beginning of each month. Let's take a look at the NMME temperature anomaly forecast. This on the left is showing you anything in yellow and oranges indicates above normal temperatures. And when it's this lighter yellow, it indicates slightly above normal. I'm talking 0.5 to 1 degree Celsius above normal temperature anomaly. So we're not talking anything major in like any of these torch-like situations with a mega southeast ridge in December, according to this model, just slightly above normal across much of the U.S. Wherever you see white, that indicates near average temperatures. So desert Southwest as well as parts of the deep South. The forecast in the middle from the NMME temperature anomalies, this is showing pretty much a lot of the country is near normal or near average temperatures for January, according to this one. And we have a slight area below normal temperatures across North Dakota. We do see above normal readings across the western U.S., according to this model, for the month of January. And then finally, February temperature anomaly forecast on the right, showing a little bit stronger signal for above normal temperatures across the west, specifically the Pacific Northwest up to western Canada, and mainly near normal temperatures anywhere east of the Rocky Mountains and generally south of Minneapolis, the Interstate 94 area, generally up near normal temperatures in the month of February. Looking at the precipitation anomaly forecast from the NMME, look at the same song and dance, everyone. This is the month of December, showing above normal or wetter than normal conditions from the Gulf Coast to the Mid-Atlantic. Over here in the middle, and for the month of January, NMME is forecasting the same areas getting wet. So it could be a very active storm track in this area, southeast and mid-Atlantic, for this particular winter. And then you're looking over here, we finally see some above normal precipitation with systems crashing into the central California coast, San Francisco Bay, southward Monterey, right on down the coast, down Interstate 5. Drier than normal, according to the NMME precip anomaly forecast for Pacific Northwest and Western Canada. And then finally, the month of February is here on the right, showing drier than normal conditions in the yellow shading here across the Ohio Valley, and then above normal precip extending from the Gulf Coast southeast, right off of the Mid-Atlantic coast. The signals on all these models are generally indicating above normal precip for December, all the way up the East Coast, in December and January, and then kind of confined from the Mid-Atlantic southward for February. Now let's look at the C3S. We'll take a look at this particular forecast model. Now this is a multi-model forecast system. It includes forecasting inputs for many, many models. The ECMWF, the UK Met Office, Meteo France, that model, the German Weather Service model, the DWD, the U.S. National Weather Service's NSET model, the JMA, Japanese Meteorological Agency model, as well as the ECCC, the Canadian Environmental Climate Change model. Now, this C3S produces 1 or 3 month outlooks. It covers probability for specific 2-meter temperature anomalies, precipitation anomalies, 500 millibar height anomalies, as well as mean sea level pressure anomalies, 10-meter wind speed anomalies, as well as sea surface temperatures. This is a great, great model. It is also released at the beginning of every month. So let's take a look. The October issuance of this model, the C3S, this is the 500 millibar height anomaly forecast. Now, I did zone out. I kind of went further out to get a global look with this particular model run. I could zoom in on North America, but I decided to keep it at this global scale. I just wanted to show you some things. Whenever you see white coloring, that indicates near normal 500 millibar heights. Whenever you see yellow, that's well above normal heights. So the month of December, we're starting off with near normal 500 millibar heights across the United States as a whole. For the month of January, this particular C3S forecast is still keeping things similar across the mid latitudes of the specifically across the United States, near normal 500 millibar heights. And then over here on the far right, we do see some pockets of below normal heights off the southeast coast. But in general, we still see the same thing here. We see near normal 500 millibar heights. We do see above normal heights. Now, we do see the signals in January for above normal heights as orange coloring across far northwestern Canada. And we also see it again showing up in Western Canada of well above normal heights. There's a higher probability. These are probability-based charts. So I'll back up now and tell you that the orange shading, the darker orange shading, indicates looks like a 50 to 60% chance of higher than normal heights over northwestern Canada in January, and then a 50 to 60% chance of those above normal heights in the month of February. Looking at the C3S temperature anomaly forecast, here is for the month of December, showing near average is slightly above average, not by much, but there's a probability of these slightly above normal temperatures at 40 to 50% coverage across a big chunk of the United States. There's a higher probability, 70 to 100%, of above normal temperatures across northeastern, or actually southeastern Canada, which I find that quite interesting because usually if you get upper level ridging or blocking, that usually beneath that ridge you get anomalously warm temperatures. So I'm going to be watching this area for potential negative NAO. I look at those little indicators here on these charts. The middle graphic here showing the probability for below, above, near average temperature anomalies. Generally, we see near average temperatures in general, the white shading across the southeast and mid-Atlantic. And we see the same thing for the month of February. Near normal, generally a 50-50 chance at near, basically above or below normal temps. But in general, we're looking at near normal temperatures across the mid-Atlantic in the months of January and February. Now let's take a look at the probabilities for above or below normal precip. Now this is interesting. December on the left. The dark green area over those warmer than normal sea surface temperatures associated with El Nino, there's a 70 to 100% chance of above normal precip in the equatorial eastern Pacific, stretching our way westward to the central equatorial Pacific. We do see above normal precipitation probability signals again from the Gulf Coast right up the eastern seaboard. We do see in the month of January in the middle, similar areas. See this? See where we have above normal precipitation, highest probabilities in dark green. And we see that area again from the Gulf Coast up to the mid-Atlantic in January. And then finally, look at this on the far right. We see the same areas across the equatorial Pacific for higher probability of above normal precip, dark green. And we see that the green coloring from Florida right up to the mid-Atlantic in February. And so some interesting things here. So we're expecting, even on this model, wetter than normal conditions. The probability is higher to occur from Florida to the mid-Atlantic for the winter months. Now, let's shift gears and look at the Nino 3.4 water temperature anomaly forecast, some of the latest model output. Starting here on the left with the C3S, this is the and actually, no, this is not 3.4, and I apologize for that. I meant to include 3.4, but I didn't here. Instead, this is the Nino 3 region, and I'll show you where those regions are located here in a minute. But in general, this is showing the Nino 3 region generally like leveling off as far as the sea surface temperature anomalies kind of leveling off and have reached their peak. You do have some models wanting to go up higher and warmer with these temperature anomalies. Gets a lot more going down though. The forecast here in the middle is the Nino 3.4, the correct region I wanted to show you. The Nino 3.4 sea surface temperature anomaly plume. This is a European forecast issued on the 1st of October. And you kind of see where we're at here in October. It's got us at about 1.6 degrees Celsius above normal in that Nino 3.4 region for the water temps. And it's showing a general climb to just around 2 degrees Celsius before dropping back down into January and February. And then the forecast here on the right is a CFS V2. This is the Nino 3.4 SST anomalies showing, look where we're peaking at here. Let's see where we're at here. This is about 1.5 C, generally where this dashed line is. Now this dashed line represents the ensemble average of all these various models. So you see this dashed black line, that's the one I'm paying attention to. It's kind of the average of everything here. Showing it did show the drop off here, the CFS V2. We have seen the cooling recently in Nino 3.4, so this is interesting. And a climb again, just about peaking at 1.7 C in December before dropping down and weakening throughout, through January and February. We're looking at potentially going from a strong El Nino down to a moderate El Nino. Let's take a look at the latest update from the Nino 3.4 region for the sea surface temperature anomalies. This is as of October 11th, 2023, and look at the value. Plus 1.06 degrees Celsius above normal in Nino 3.4 region. Look at the blue line. This is the history going back to the 19th of July here. We were sitting at around 1 degree Celsius above normal in that Nino 3.4 region for the water, and it kind of leveled off until about the 9th of August, then it kind of started climbing. Notice a more significant climb here between August 16th and August 28th, then a slight cooling again, then a slight rise, slight cooling, slight rise, slight cooling, and then it leveled off again before cooling some more. So, you know what? I know what these models are saying over here, whether we're talking about C3S. Now, again, this isn't the Nino 3.4 region, which I intended to have. But look at this, the European model, look how high it's peaking the SST anomalies in Nino 3.4. Look at over here, CFS V2, okay? I think CFS V2 is more realistic, to be honest, out of these two at least, comparing for the 3.4 Nino region forecast. Because where it's at now compared to, what the CFS V2 is showing a peak at, to me, this makes more sense. All right. Let's take a look at the Nino 1+2 SST anomalies, and I'll show you what these Nino boxes are, these regions, in a minute. But in general, again, this blue line represents the history of the water temperature anomalies in degrees Celsius on the scale in the Nino 1+2 region. This is right off, basically immediately off the coast of South America in the far eastern equatorial Pacific. Look at this drop off. We're down to positive 1.84 degrees Celsius above normal. This area has cooled since 30 August. Look at where it was at 30 August, above 3 degrees Celsius above normal in Nino 1+2 region. It dropped significantly into mid-September, and it dropped again, and now it's dropping again. Now it's kind of leveling off around October 11th. But okay, this is courtesy, by the way, of Levi Cowan and Tropical Tidbit. So we have a cooling trend in Nino 1+2 region. Here is I attached on both of these graphics. This kind of shows you where the Nino regions are. So this was Nino 1+2 right here, this white box in both cases, right off the immediate coastline, west coast of South America. Let's go back now. This is what it's doing. It's cooled significantly since the 30th of August. This is the Nino 3.4 area, okay? This is associated with, technically this is what classifies El Nino and La Ninas. And then this is Nino 4, the furthest west box. Okay, I didn't show you Nino 4. I just showed you Nino 3.4, and I showed you Nino 1+2. Now look at this. This is what's interesting to me. The NMME sea surface temperature anomalies forecast, okay? This is for the months of December, January, and February on the left. And on the right here, I'm showing you for the months of January, February, and March. Now, according to the NMME forecast for sea surface temperature anomalies, now this was just issued in early October, just recently, the brown coloring indicates sea surface temperature anomalies in excess of 2 degrees Celsius, between 2 to 3 degrees Celsius. So wherever you see this brown oval shape in both of these diagrams, that indicates the location of the warmest sea surface temperature anomalies. Now, keeping in mind where these Nino boxes are located, okay? So you see Nino 1 plus 2, you see Nino 3, okay, that's this box, and then you see Nino 3.4. To me, both of these forecasts are showing the greatest sea surface temperature anomalies above normal water temps between this eastern central Pacific area and the central Pacific area. So in my opinion, I feel strongly about this. I don't think we're going to see a truly traditional east-based El Nino, nor a truly traditional Central Pacific or West-based El Nino. I just don't see it. If this model verifies, it's going to be between those two, East and the Central-based El Ninos. So we could very easily see a potential hybrid El Nino this winter between those two areas. All right, between that Nino 4, which is out in this location, okay, towards the international date line, and Nino 1 plus 2. So just keep an eye on that. Here is a review of El Nino Walker circulation, okay? And I wanted to show you this specifically to really let you see the vertical air motion that goes on in the tropical areas, whether we're talking the Pacific Ocean or the Indian Ocean here or the Pacific Ocean. And I threw the various MJO phases kind of like beneath some of these arrows, these upward and downward sinking areas. So when we're in an El Nino, what do we have? We have rising vertical air motion, lots of clouds, and lots of precipitation, above normal precip over eastern Africa. Okay, that's associated with MJO phase 1. You see how we have a major sinking vertical circulation, sinking air, generally in the western Pacific, tropical Pacific, and that's an association with MJO phases 4 and 5. See that? Right in this area is MJO phases 4 and 5, the maritime continent, otherwise known as Australia. This is why Australia typically sees drought conditions during El Nino winters, or El Nino years in general, and brush fires, is because the air is so dry. You have this major sinking circulation of air in the vertical, and whenever the air sinks in the vertical, it dries and warms. All right. Whenever the air rises in the vertical, it's going to cool and condense and form clouds and form precipitation. Look at this in the central equatorial Pacific near the dateline. We have rising air motion with the El Nino situation. This is associated with MJO phase 8. And then you have more sinking air right over the, basically the western North Atlantic, kind of further to the east there, right? So I just wanted to show you this. It's courtesy of NOAA. Rising air over Africa right here. Rising air over the central equatorial Pacific right here. And then you get sinking air. So you see the compensation here. What goes up must come down. What goes up must come down. And where these circulation cells, the rising and sinking air set up, means everything to our winter weather. What longitude lines do the rising cells set up? What longitude lines do these sinking cells or circulation areas set up? It's so very important to our winter forecast. If you look at the Indian Ocean dipole circulation, now everybody's going off the rails about this right now on social media. You're seeing positive IOD, winter's over. No chance for winter. Cancel it now. Okay, let's take a look at the circulation associated with this positive phase of the Indian Ocean dipole. And you see rising vertical air motion in the same location. Now look at this. It's in the same general location as what El Nino would support. See this? Eastern Africa. You're seeing rising air motion, a lot more above normal precipitation in East Africa. And the positive IOD shows a similar circulation cell. We have sinking air motion out over MJO phases 4 and 5, those areas, the maritime continent. This just compounds the problem for Australia for drought and for fire, because you have these circulations that are associated, these vertical circulations associated with this positive Indian Ocean dipole, plus with the El Nino. and they're complementing each other, okay? This rising air motion over eastern Africa is being complemented by the positive IOD with the rising vertical air motion here at above normal precip. This sinking air motion is complemented, the positive IOD, with El Nino. See this? Okay. What am I getting at here? Right. By the way, this is positive IOD. And I should explain that positive IOD was basically what you have is above normal water temperatures in the western Indian Ocean, below normal water temperatures in the eastern Indian Ocean. Okay. You also have those cooler than normal waters extending into the western Pacific equatorial areas during El Nino and also during positive phase of IOD. So when's the last time we've had a positive IOD? This strong. Look at this, okay? This is courtesy of the Australian Bureau of Meteorology here on the right. Look at where we're at, okay? We're generally in this location, okay? 1.6 Celsius above normal water, generally in the Western Indian Ocean. Got it? And then it levels off in November, and then it starts decreasing or losing intensity. Look at this drop off here between November and January. It's a significant drop. By the way, in order to be a positive IOD, these water temperatures have to be in excess of 0.4 degrees Celsius above normal in this Western Indian Ocean, by the way. But look at this drop off. This is the forecast, latest forecast, showing the forecast mean is the green line, showing a major drop off in January and definitely in February. It goes almost to a neutral state IOD. What does this mean? This means that we would expect the positive phase of the Indian Ocean dipole to initially impact our early winter weather, specifically into December. But after that, after the new year, after we say Happy New Year 2024, this IOD, these water temperature anomalies in the Western Indian Ocean are forecast to decrease and get closer to normal. All right? And again, the main focus here is what I kind of put down here at the bottom. Rising air east of Africa, sinking air over Indonesia and over the Western Pacific Ocean. Here's the MJO phases associated with these rising and sinking circulations in the vertical, okay? Let's look at the MJO forecast. So if we have a positive IOD, right, and also the El Nino, we'd expect rising air in the central equatorial Pacific near the dateline, and that's in association with MJO phase 8. We'd expect the rising air and convection to be over the East African area associated with MJO phase 1. Okay, so let's take a look. This is the latest forecast, Jeff's V12, extended outlook from the 10th of October right on to the 10th of November. Generally showing, you see these yellow lines here that represents all the various models as part of the ensemble system here. You see where the focus of all these yellow lines are, don't you? They're over here in phases 8 and phases 1. Phase 8, phase 1. This is the official forecast here. It goes weaker into phase 1 and kind of hangs around this small inner circle of null phase. Look at the forecast here from CFS V2 extended from the 11th of October to the 9th of November, generally showing is a little bit further to the east, the rotation of the MJO in this case, this model, showing it potentially going into 6 and 7, and also in phase 8. And then finally the European extended over here on the far right, MJO forecast from the 9th of October to 9th of November. Look at the clustering of the yellow lines here, the model members of this particular system showing, yeah, it's mainly focused on the cold side of the MJO phase diagram with convection over the Western Hemisphere and Africa. Did we just say Western Hemisphere and Africa? Why, yes, we did. And looky here. Look what happens with MJO phase 1. There's your rising air motion with El Nino. There's your rising air motion. And wouldn't you know it? Look where the forecast is for phases 8 and 1. 8 is going to be the one again over the central equatorial Pacific, right here, okay, closer to the international dateline. 1, though, is right here in the sweet zone that I've been harping on with the positive IOD. One other thing to mention, and I did some additional research this afternoon on the positive IOD, and it is true. Positive IOD, the research does state that is generally connected with above normal temperatures and drier than normal conditions in the east. The last time we had a strongly positive IOD was the winter of 2019-20, and it was a very mild winter in the east. But in 2019-2020, we did not have an El Nino. We had ENSO neutral conditions, so just keep that in mind. So we'll have to watch and see what happens. Here are the MJO temperature composites. Okay, so here's my theory. And again, this is just my opinion. All right. If the positive IOD in early winter before it starts fading away, if that favors rising vertical air motion and convection here east of Africa, right? That's associated with MJO phase 1. That would favor more MJO phase 1, in my opinion. And then also with the El Nino, again, rising air motion here in the central equatorial Pacific, MJO phase 8. Sinking air motions in MJO phases 4 and 5, which, by the way, are our warmer phases of the MJO. So, taking a look at temperature composites for December, January, and February. Blue coloring below normal temperatures, orange coloring above. If we hang out on this side of the MJO phase diagram, okay, for the winter months, from 8 to 1 to 2, right in this area, and the MJO does not rotate out here into the maritime continent, we're going to have a colder than normal winter in the eastern U.S. Phases 8, colder than normal in the east. In the mid-Atlantic, phase 1 the same. Phase 2 for a larger chunk of the United States. All right, and here are the different phases. This is where you're favoring it right now, with the circulations, with the IOD being positive, with the El Nino here at 8, maybe 7 and 8 right in here. Okay, if we stay on that cold side of the MJO phase diagram at 8, 1, and 2, oh boy, it could be a pretty cold winter in the east. And that's all I'm getting at here. I'm connecting the dots here, showing you the different oscillations, positive IOD, where there's rising air motion, showing you where there's sinking vertical air motion, drier conditions, okay? Now, let's put this all together, all right? What are these long-range models showing for probabilities of above normal precip, the C3S? Whoa, look at this. I circled it. It's generally located over the eastern portions of Africa and extending a little bit further to the east of that even. This is generally looks like to be a 70 to 100% chance of above normal precip in the months of December, January, and February right here. And that would make sense with a positive IOD with this circulation like this. See this? It's all connected. Okay? And the models are picking up on that, I believe. You also see above normal precipitation closer to the dateline across the equatorial areas. See this? And that above normal precip extends all the way to the east, or to the east, just off the west coast of South America, and also generally up the eastern seaboard for us. Now, let's keep moving. The European sees 5. This is the latest global precipitation anomaly forecast. Look at again. Look at where the sweet spot is for above normal precip. Eastern Africa, associated with MJO phase 1, and also over the central equatorial Pacific, right near the 180-degree longitude line, the date line. Okay, so this would favor rising air motion, MJO phase 1 area here, Eastern Africa, and phase 8 over the central equatorial Pacific. Moving on. NMME precip anomaly forecast. Again, boy, these models are sure in agreement, aren't they? Wow. Okay, so C3S, higher probability of above normal precip, East Africa. ECMWF sees 5, East Africa, Central Equatorial Pacific in phase 8. NMME, East Africa. Look at this, folks. And above normal across the Central Equatorial Pacific. MJO phase 1, MJO phase 8, and the MJO phases 2 and 3, drier than normal. Sinking air motion. Indonesia, drier than normal. General in this area here. Okay? Above normal along the East Coast, Southeast and Mid-Atlantic specifically. December, January, and February, 3 models are saying the same thing. What does that mean? That means we have higher confidence of an occurrence of this actually happening. In summary, then, the majority of the long-range models, as I've shown you tonight, continue indicating a pattern in line with an El Nino winter. I'm going to give you a caveat. Let's see. Did I put it in here? No, I did. The multivariate ENSO index. I made a comment about this on the teleconnections discussion, which I drafted and posted on the Spot on Weather website today. Okay. The MEI, multivariate ENSO index, that is how the atmosphere responds to the underlying warmer than normal waters associated with El Nino. Right now, the MEI index is only performing, it's basically in line with the 1992 El Nino. The atmosphere is not responding as strongly as it did in the Super Nino winters. We're talking 1982, 1997, 2015. The MEI is not responding. The atmosphere is not responding as strongly as we'd anticipate based on these sea surface temperature anomalies. Okay, so that's why I throw the caveat in here. All right, now where the heaviest precip is showing up for the winter months, December, January, February, that's pretty good in accordance with an El Nino winter. Okay, moving on. We're going to get a more suppressed U.S. southern storm track. It's going to happen. It's going to happen. When you look at these long-range models and they're giving us such high confidence, they're all in agreement, every one of them. Let's go back and look again, okay? Let's go back. All right. Okay. I have to go through here. Okay. Okay, concepts. Where is the above normal precipitation? Southeast to mid-Atlantic, right up the eastern seaboard. See this? December, January, February, all there. What about the European Seas 5? Same location in all 3 months. What about the NMME temperature anomaly forecast? Same location. See this? So there's pretty high confidence. Same location here at C3S. Okay, December, January, February. So in general, we have pretty high confidence that we're going to see a more southern storm track, and it's going to yield above normal precipitation from southern U.S., specifically southeast up to the mid-Atlantic, maybe extending a little further north of that. Meanwhile, the models are showing warmer than normal temps across Canada, which is indicative of a potential negative NAO pattern potentially throughout the winter. I'm not saying it's going to last every day of the winter. I'm not saying it's going to last all winter long, but they're also indicative of a positive PNA pattern. Negative NAO plus El Nino. If we get that negative NAO, plus we have the El Nino going, it results in below normal temperatures for the mid-Atlantic. And if we have a positive PNA on top of that, that's going to result in below normal temperatures as well, and in more of a constructive interference situation. Temps are forecast to be slightly above normal in December, greater probability for near normal temps in January and February on most of the models for the southeast and mid-Atlantic. That's a medium confidence forecast. That's not high yet. Temps are usually really tricky. It depends on, this North Atlantic oscillation combination with El Nino as well as that PNA pattern. And the long-range models are in excellent agreement as far as that wetter than normal conditions for the winter months. For the southern U.S. to mid-Atlantic, we have a very high confidence. They haven't budged. I've been starting this, looking at these models closely in early September. Early August. So August, September, and October, they have been locked in on this above normal precipitation from the southern U.S. up to the mid-Atlantic. All right, that wraps things up this evening. I just wanted to really, really get my points across here. I know I was kind of emphasizing some things heavily. If I was like a teacher right now and I was giving you a test at home, I probably would have foot stomped some of the things I said tonight. So you knew what to study for, right? But yeah. Anyway, emphasis is important. Precip looks like it's going to be above normal this winter. This is more El Nino-like here. You look at the green coloring and where it's located. I know the positive IOD is a factor, and it could play into the winter. I'm not ruling it out. But the way it looks right now, if we look at the positive IOD one more time. Let's just go to the circulation pattern here with it. All right. Look at the forecast here and see where it peaks. It's going to peak next month in November, and then it's going to start weakening. Specifically, a big drop here in January and February. By February, it's back to normal. It's back to neutral conditions for the IOD. Okay, this isn't going to be a from start to finish positive IOD winter. All right, now again, what's the importance of a positive IOD, especially when it gets this strong? 2019-2020 winter, we had a very strong stratospheric polar vortex. We had a positive phase of the North Atlantic oscillation NAO with the positive IOD. So, that is a potential possibility. I won't rule that out, but we'll just keep watching it. I like where these areas are for favored rising vertical air motion, the circle areas here. I like it. I'm not going to lie. I like it. If you get rising air in these areas, you would think that, our MJO is going to be more favorable to be, more convection in these areas in phases 8 and 1. based on the Walker circulation, the combination of the positive IOD and El Nino. All right, that wraps things up this evening. I wish everybody a wonderful evening. I hope you caught my last teleconnections discussion back last Friday. I hope to continue to do those on a weekly basis. And that's all I got for now, everybody. Until next time, take care and God bless everyone.